This is another past paper question of correlation and regression. It has come in January 2023 paper, IAL S1 Edexcel. Question number 6. This was. Okay. Can you
Miss,
please
please
read?
share your screen.
Yeah, 1 minute. Please read the question.
A research student is investigating the maximum weight Y grams of sugar that will dissolve in 100 grams of water at various temperatures, X
Okay.
degrees Celsius,
Firstly,
where
it is
X is,
investigating Y grams. Okay.
yeah,
Y on X.
X.
So when you are reading, you have to start interpreting things. So it is Y grams of sugar. Okay. That will dissolve in 100 grams of water at temperature. So X is the temperature. So can you define the parameter for me? What is Y?
Y is the sugar grams.
Grams of sugar that will dissolve in 100 grams of water. Okay. And X is the
Yeah.
temperature where X is between 10 and 80. Can you explain me the meaning of this where X is between 10 and 80?
So the temperature, there's a range of temperature.
So
So
anything that is
X,
outside this range would be extrapolation.
yeah.
That means what we are doing this for X between 10 to 80 degrees Celsius.
Hmm.
Are you with me?
Yes.
Now read ahead.
The research student calculated the regression line of y on x and found it to be y equal 151.2 plus 2.72x.
Very good. Give an interpretation of the gradient.
Yeah.
So what is
So
your interpretation for the gradient?
for every 1 degree Celsius increase, y will increase by 2.72 grams.
Y will increase by 2.72 grams, or you can say the sugar, okay, what that will dissolve will in water would increase by 2.72 grams. Okay,
Yeah.
so it will allow an extra 2.72 grams of sugar to dissolve in water. Look at the words what I said. It will
Yeah.
allow an extra 2.72 grams to dissolve in water. Why did I say extra?
Because it increases.
This much is definitely going to dissolve. 151.2 is definitely going to dissolve, right?
Yeah, yeah.
Okay, fine. Come on, read the B part.
Use the regression line to estimate the maximum weight of sugar that will dissolve in 100 grams of water when the temperature is 90 degrees Celsius.
Okay, so how would you start this?
So we'll write y equal 151.2 plus 2.72 brackets 90.
First, I write the equation. Now, what do they want from me?
When x is equal to 90,
They want
what is
to
the
use
value of
the
y?
regression line and they want to estimate maximum weight of sugar that will dissolve in 100 grams of water. They want to find Y, sugar that will dissolve in 100 grams of water when the temperature is 90 degree, right? So when X is 90 degree, they want me to find the amount of sugar that will dissolve in water.
Yeah,
Yeah?
miss.
Okay.
Hmm.
So what will I do? I have to write, I will substitute what?
90 into the regression line
I will
equation.
substitute 90 into the regression line. My regression equation is 151.2 plus 2.72. So I will get Y is equal to 396 what? 396 what? Gram.
Grams.
So it means that at 90 degrees Celsius, sugar that will dissolve in 100 grams of water would be 396 grams. Correct?
Yeah.
Now, C part. Comment on the reliability of your estimate, giving the reason for your answer.
It is not reliable
Okay.
as the temperature is outside the range.
Our data is for X between 10 degrees Celsius to 80 degrees Celsius.
Yeah.
First, you give this, okay? Since 90 degrees Celsius is outside the range, it is an extrapolation, so the estimate will not be reliable. One, extrapolation, unreliable, not reliable. Three things.
Okay.
Okay? Come on. You've done up till the C, right?
Yeah.
Did you do the D part?
No.
Okay, fine. Let's go ahead for the D part. Read.
Using the regression line of y on x and the following summary statistics show that the product moment correlation coefficient for these data is 0.988 to 3 decimal places.
That means I want to find PMCC R of Y
Yeah.
of X. Yes?
Hmm.
So R of Y on X, what will be the formula?
R is equal to SXY divided by square root of SXX into SYY.
Okay. Do I have SXY?
No.
Can I find SXY?
No.
It's question mark.
Yeah.
Okay. Do I have SXX?
No.
What is the formula for SXX?
Sigma x squared minus sigma x the whole squared divided by n.
And what is the formula for SYY?
Sigma y squared minus sigma y the whole squared divided by n.
Sigma Y square minus sigma Y the whole square divided by N. Okay, cool. Now tell me, do you have sigma X square?
Yeah.
What is sigma X square?
24,500.
Do you have sigma X?
No.
You have N.
Yeah.
Okay. How about here?
What?
I have SYY.
No.
I have sigma Y, right?
Oh yeah. Sigma y squared and sigma y.
So what will this be?
851093 minus 3119 squared divided by 12.
Hmm? Say, so what will this be? SYY.
851,093 minus 3,111 the
So
whole
it's going to
squared.
become 40412.91. Correct? So this is found.
Yeah. Okay.
Okay. Now I don't give me the formula for SXY.
Sigma xy minus sigma x into sigma y divided by n.
I don't have sigma XY. I don't have, right?
Yeah.
Do I have sigma x?
No.
Do I have sigma y?
Yeah.
How much is it? 3119
Hmm.
divided by 12. Are you with me?
Yeah.
Our target is to find the PMCC. I need sigma x and sigma xy. Are you with me?
Yeah.
Okay, I have the n and I have substituted things everywhere. I don't have this. I don't have sigma xy and I don't have sigma x.
Hmm.
These three things, these two things I need. Okay, but I have my regression line y on x.
Yeah.
My regression line y on x is giving me that y is equal to 151.2 plus 2.72x. Are you with me?
Yeah.
So I can say mean of y is equal to 151.2 plus 2.72 mean of x. Yeah,
Why?
you know when we find the regression coefficient, we put y is equal to a plus bx, and to find a and b, we put these means.
Yeah.
So we can do that.
Okay.
Okay. Now this will help me to find the mean of x. Now let's
Hmm.
see over here. My mean of y is 3119 by 12.
Hmm.
So this
Yeah.
would be 151.2 plus 2.72 mean of x.
Yeah.
Instead of mean of x, I can write sigma x by n,
Yeah.
correct?
Hmm.
Okay, I just want the sigma x. So everything I will make sigma x my subject. I can make sigma x my subject.
Yeah.
Okay, how will I do it? Come on, help me. So it's going to be 3119 by 12 minus 151.2 is equal to 2.72 sigma x by n.
Hmm.
Are you with me?
Yeah.
So it's going to be 3119 by 12 minus 151.2, the whole divided by 2.72, and this n is what, 12,
Yeah. So multiply by
multiplied
12.
by 12 is going to give me sigma x. So my sigma x would become 479.63235. Please do up till here. I will wait for you. Now when I'm going to substitute, it is 479.6323. Are you with me?
Yeah.
So I would substitute in my sxx first. So it is what? 479.6323, the whole square by 12. So I'm going to get my sxx as how much? 5329.4005.
Yeah.
Yeah?
Hmm.
Now let's do the SYY. SYY was already there.
Yeah.
SYY was already there. This is your SXX. Now we are into SXY. We still have an issue over here. What is my sigma x?
5329.4.
So this is sigma x by n.
What do you mean?
Nothing. Phi 3. Come on, tell me.
5329.4.
The x. XX.
Huh?
Looking at sigma x. What is sigma x? Sigma x is
Oh, okay. 479.63.
479.63.
63.
Now, to find the r, what are the things I needed? I needed sxx, I needed sxy, sxx, and syy. Okay? We
Yeah.
already found syy because all the information was available with us. Correct?
Yeah, miss.
For sxx, we did not have the sigma x, but then we used the formula of the regression line and we put this mean over here and we found the mean of x and then we found the sigma x. Yeah? Are
Yeah.
you with me? And then we found the sigma x, and with the help of sigma x, I found sxx. Now I already have my regression line. My regression line was y is equal to 151.2 plus 2.72 x. So where this is a, this is b, correct?
Yeah.
Now I will use my regression line and try to find out my b, my sxy. I know the formula for b is what? Sxy divided by sxx. I'm not getting xy, correct?
Yeah.
To get this xy, I need some or the other formula, so I use this b. I know my b is how much? 2.72. I don't know sxy, but I know my sxx is 5329.4005.
Hmm.
So, to get the sxy, I will not use this, but I will use sxy is equal to b into sxx. So that is 2.72 into 5329.4005. Yeah, I hope
Yeah.
you're with me.
Hmm.
So I am going to get my sxy as how much? My sxy will become 14495.9693. I hope you're with me.
Yeah.
So I got all the values for the regression equation. This I got from the B. This I got from the regression equation by putting the means. And now I just substitute. So my R is equal to 14495.9693 divided by the root of SXX, that is 5.329.4005 into SXY, that is 40412.9166 dot dot dot. Okay, so you get the R as how much? You should get your R is equal to 0.988. I hope you. The E part is researcher, student, supervisor. They plotted the original data on a scatter graph. With reference to this scatter diagram and the correlation coefficient, which is 0.988, discuss the suitability of the linear regression model. Since I have to discuss the suitability of the linear regression model, this is a scatter diagram. My regression coefficient R is 0.988, which is very close to -1. Since it is very close to -1, it is indicating an almost perfect positive linear relationship. But if it will be 1, it will be perfect positive, but this is strong positive linear relationship, or I would say it is almost perfect linear relationship. So there is a scatter diagrams. The data which is given to me, it forms a clear linear pattern as it is given in the scatter plot, suggesting a strong positive linear correlation. R is close to 1, indicating the same. So since I want to discuss the suitability. So since the data is following a straight line pattern, the linear regression model is appropriate, okay, which would fall through for the data within the range 10 to 80 degree. If it goes any way beyond 10 to 80, it would be extrapolation. So with this, we complete this question.